Hello, it's time again for our SHS 3 Core Mathematics lesson. This is brought to you by the Center for National Distance Learning and Open Schooling. I am Lucy Asari Nelson, your presenter. This is our second and final lesson on matrices. We'll be looking specifically at multiplication of matrices. By the end of this lesson, you should be able to 1. Multiply a matrix by a scalar or a number. 2. Multiply a matrix by a matrix. And then 3. You should be able to find the determinant of a 2 by 2 matrix. In our last lesson, we learned about how to find the sum and difference of two matrices. Today, we'll continue with this topic and learn how to multiply matrices. Now let's look at multiplication of matrices by a scalar. A matrix may be multiplied by a number as follows. 2 multiplied by the matrix 3, 4, 5, 1 is equal to 2 multiplied by 3, 2 multiplied by 4, 2 multiplied by 5, 2 multiplied by 1. In other words, just use the 2 to multiply each of the entries. When we simplify that, it gives us 6, 8, 10, 2. Here, the number 2 is called a scalar. To multiply a matrix by a scalar, simply multiply each element or entry by the scalar or the number. Let's take an example. The matrix A is equal to 7, 3, 4, 6. Let's find 2A. 2A means 2 multiplied by the matrix A. And so that will be equal to 2 multiplied by 7, 3, 4, 6, which will give us 14, 6, 8, 12. Remember, you are only going to use the scalar to multiply each of the elements. Good. Let's also find half A. So half multiplied by the matrix A is equal to half multiplied by 7, 3, 4, 6. And that will give us 7 divided by 2, 3 divided by 2, 2, 3. Similarly, if we have 5 multiplying the matrix negative 4, 3, 6, negative 2, then the answer would be negative 20, 15, 30, negative 10. Good. Let's take some examples. Find the matrix in each of the following examples. If A, 5A is equal to negative 5, 5, negative 10. B, 2x is equal to negative 16, 6, 0, negative 5, 3, 8. And then C, 1/3 A is equal to negative 1, negative 3, 0, 2, negative 2, 5, negative 1, 3, 6. Let's take the solutions. So for A, We have 5 multiplied by the matrix A is equal to the matrix -5, 5, -10. This implies that A is equal to 1/5 multiplied by the matrix -5, 5, -10. That is, we are just dividing through both sides by 5. Remember, for the matrix, each of the elements will be divided by 5, or 1/5 times each of the elements. And so when we simplify that, we have the matrix -1, 1, -2. Therefore, the matrix A is equal to -1, 1, and -2. I hope that is simple. Good. Let's look at B. We are given 2x is equal to -16, 6, 0, -5, 3, 8. Again, we will divide through by 2. And so that will give us x is equal to half multiplied by -16, 6, 0, -5, 3, 8. When we simplify that, we are going to have x is equal to the matrix -8, 3, 0, -5 divided by 2, -3 divided by 2, and then 4. Therefore, the matrix X is equal to -8, 3, 0, -5 divided by 2, -3 divided by 2, 4. Good. And for the third one, we have 1/3 A is equal to -1, -3, 0, 2, -2, 5, -1, 3, 6. This implies that the matrix A is equal to 3 multiplied by -1, -3, 0, 2, -2, 5, -1, 3, 6. That is, we are multiplying through each side by 3. So we can take away the fraction at the other end and make A the subject. When we simplify that, it gives us -3, -9, 0, 6, -6, 15, -3, 9, 18. Therefore, the matrix A is equal to -3, -9, 0, 6, -6, 15, -3, 9, 18. Great. 2. We want to look at general matrix multiplication. Let's look at how we can multiply one matrix by another matrix. 2 matrices can only be multiplied if the number of columns in the first matrix is the same as the number of rows in the second matrix. When this happens, we say that the matrices are compatible. For example, we can multiply the following matrices. A 2 by 3 matrix can be multiplied by a 3 by 3 matrix. B, a 2 by 2 matrix can be multiplied by a 2 by 1 matrix. And C, a 3 by 1 matrix can be multiplied by 1 by 2 matrix. That is when we take the order into consideration, and many more. This is because the number of columns in the first matrix is equal to the number of rows in the second matrix in each case. However, if we have a 2 by 3 matrix and a 2 by 2 matrix, matrix multiplication in this case would not be possible because the number of columns in the first matrix is not equal to the number of rows in the second matrix. Also, after multiplying two matrices, the order of the results will be the number of rows in the first matrix by the number of columns in the second matrix. Remember, we are using the cross to represent by in matrix multiplication or in the order of a matrix. For example, if a 2 by 3 matrix is multiplied by a 3 by 3 matrix, the order of the results will be a 2 by 3 matrix. I want you to note this table or diagram. If we have an m by n matrix and we multiply it by an n by p matrix, if they are compatible, then the result will be an n by p matrix. The multiplication is done by multiplying a row in the first matrix by a column in the second matrix, as we are about to do. Good. If the matrix A is equal to A, B, C, D, and the matrix B is equal to W, X, Y, Z, then the matrix A multiplied by the matrix B is equal to the matrix A, B, C, D multiplied by the matrix W, X, Y, Z. That would give us AW plus BY, AX plus BZ, CW plus DY, and then CX plus DZ. Simply, we are taking the row and the column, so we multiply the elements and take the sum in each case. Good. So that will give us AW plus BY, AX plus BZ, CW plus DY, and then CX plus DZ. This matrix is a 2 by 2 matrix, and that is the result of multiplying A by B. Similarly, if we have the matrix A, B, C, D, which is a 2 by 2 matrix, and we are multiplying this matrix by X, Y, which is a 2 by 1 matrix, the result is going to be AX plus BY, CX plus DY, which is going to be a 2 by 1 matrix. Now let us take some examples. Example 1. If the matrix A is equal to 3, 2, 0, 1, matrix B is equal to negative 2, 4, negative 1, 2. Matrix C is equal to 0, 1, 4, 8. And the matrix D is equal to 1, 0, 2, 3, 1, 0. Find the following products where possible. A. The matrix A multiplied by the matrix B. Let's take that one first. So let's look at the solution. The matrix A multiplied by the matrix B is equal to the matrix 3, 2, 0, 1 multiplied by the matrix negative 2, 4, negative 1, 2. That means that we have a 2 by 2 matrix multiplying a 2 by 2 matrix, which is compactible. So this will be equal to 3 multiplied by negative 2 plus 2 multiplied by negative 1. 3 multiplied by 4 plus 2 multiplied by 2. 0 multiplied by negative 2 plus 1 multiplied by negative 1. 0 multiplied by 4 plus 1 multiplied by 2. We will simplify that to have negative 6 minus 2, 12 plus 4, 0 minus 1, 0 plus 2. When we simplify that further, we will have AB to be equal to the matrix negative 8, 16, negative 1, 2. So you see, the result in this case is a 2 by 2 matrix. I hope you understand. Good. Let's take B. We want to multiply the matrix B by the matrix A. Solution. B multiplied by A is equal to the matrix negative 2, 4, negative 1, 2 multiplied by the matrix 3, 2, 0, 1. In this case, again, we have a 2 by 2 matrix multiplying a 2 by 2 matrix. It is compact. They are compactible, so we can go ahead with the multiplication. So we have matrix B multiplied by matrix A, giving us negative 6 plus 0, negative 4 plus 4, negative 3 plus 0, negative 2 plus 2. When we simplify this, we have the matrix BA to be equal to negative 6, 0, negative 3, 0. Good. Now from the results of 1A and 1B, it is clear that the matrix A multiplied by B is not equal to the matrix B multiplied by A. This implies that matrix multiplication is not commutative. Good. Let's take C. We want to find the product of DA. Solution. Matrix D multiplied by matrix A would give us 1, 0, 2, 3, 1, 0 multiplied by the matrix 3, 2, 0, 1. Matrix D is a 2 by 3 matrix, and matrix A is a 2 by 2 matrix. These two are not compatible. Therefore, matrix DA does not exist. We cannot multiply them. Good. Let's take example 2. If the matrix A is equal to 2, 4, and the matrix B is equal to negative 1, 3, 5, 0, find AB and BA if possible, or if they are compatible. Let's take the solution. The matrix A multiplied by the matrix B is equal to the matrix 2, 4 multiplied by the matrix negative 1, 3, 5, 0. So here we have a 2 by 1 matrix multiplying a 2 by 2 matrix. This is not possible because they are not compatible. So the matrix AB does not exist. Good. Now we are to find the matrix BA. Matrix B multiplied by matrix A is equal to the matrix -1, 3, 5, 0 multiplied by the matrix 2, 4. Here we have a 2 by 2 matrix multiplying a 2 by 1 matrix. They are compatible. So the matrix BA exists and it is going to be a 2 by 1 matrix. Good. Let's go ahead with the multiplication. So the matrix BA is equal to the matrix -1, 3, 5, 0 multiplied by the matrix 2, 4. That is equal to -1 multiplied by 2 plus 3 multiplied by 4 for the first row. And then 5 multiplied by 2 plus 0 multiplied by 4 for the second row. We'll simplify this to have matrix BA is equal to -2 plus 12, 10 plus 0, which is equal to 10, 10. Therefore, the matrix BA is equal to 10, 10. I hope you understand. Good. We want to take another dimension. We want to move away a little from the multiplication and look at the determinant of a matrix. In this lesson, we will look at the determinant of a 2 by 2 matrix. We can only find the determinant of a square matrix. In this session, we will restrict ourselves to finding the determinant of only a 2 by 2 matrix or 2 by 2 matrices. If matrix A is equal to A, B, C, D, then the determinant of the matrix A is denoted by that A, as you can see, sometimes written as A, as you can see, which is given by A, B, C, D with the bars. And so that A is equal to AD minus BC. That is the product of the major diagonal minus the product of the minor diagonal. Let's take an example. If the matrix A is equal to 6, 3, 2, 5, then 6 and 5 form the major diagonal, and 3, 2 form the minor diagonal. Therefore, the determinant of A, or that A, is equal to 6 multiplied by 5 minus 3 multiplied by 2, which is equal to 30 minus 6, and that will give us 24. Also, the determinant of -5, 0, 2, 10 is equal to -5 multiplied by 10 minus 0 multiplied by 2. That, when simplified, will give us -50. I want you to note that the determinant of a matrix is a scalar or a number. So when you finish, you are just going to get a number, a value. Good. Let's take example 3. Evaluate the determinant of each matrix. A. 0, -4, -6, -2. Let's take the solution of that first. The determinant of 0, -4, -6, -2 is equal to 0 multiplied by -2 minus -4 multiplied by -6. That will give us 0 minus 24, which is equal to -24. Let's find the determinant of B. The matrix is -1, 1, -1, 4. So the determinant of -1, 1, -1, 4 is equal to -1 multiplied by 4 minus 1 multiplied by -1. We'll simplify that and it gives us -4 minus -1, which is the same as -4 plus 1, and that gives us -3. I hope by now you can find the determinant of a 2 by 2 matrix. Let's take C. We have to find the determinant of the matrix 3, 6, 5, 8. Solution. The determinant of the matrix 3, 6, 5, 8 is equal to 3 multiplied by 8 minus 6 multiplied by 5. That will give us 24 minus 30, which is equal to -6. Good. Evaluate each determinant in the following cases. D. The determinant of the matrix -5, 3, 4, 2. The determinant will be -10 minus 12, which is equal to -22. E. The determinant of the matrix -1, 8, 5, 0. Here the determinant will be 0 minus 40, which is -40. I hope you are following the trend and you can now find the determinant. F. The determinant of the matrix 0, 6, -8, 0. The answer is 0 minus -48, which will give us 48. G. The determinant of the matrix 1, 2, 3, 4 plus the determinant of the matrix 5, 2, -2, 6. Here we'll find the determinants separately and then we'll add. So that will give us 4 minus 6 plus 30 plus 4, which is equal to -2 plus 34. And we would have our answer as 32. Good. In this lesson, we have learned that 2 matrices can be multiplied if and only if the 2 are compatible. We've also learned that 2 matrices can only be multiplied if the number of columns in the first matrix is the same as the number of rows in the second matrix. Also, we've learned that if 2 matrices are not compatible, then the product of the 2 matrices does not exist. Again, the multiplication of matrices is not commutative. This implies that a matrix A multiplied by a matrix B is not equal to the matrix B multiplied by the matrix A. That if matrix A is equal to A, B, C, D, then the determinant of A is denoted by det A, which can also be written as A with the bars, which is given by AD minus BC. Also, the determinant of a matrix is always a scalar or a number. Well, this brings us to the end of this lesson and our lessons on matrices. I hope you'll be able to find the product of two matrices on your own. I want you to try some questions from your textbooks and join us again for another lesson. Until then, it's goodbye.